In this video, we're going to learn to approximate the area of the integral using rectangles. This is also called Riemann sums. So as you can see from the first example, in the diagram with four different plots side by side, we have different scenarios. We have the scenario with 1 equals 1 rectangle, with 2 rectangles, 4, and then 12 rectangles. All of these are trying to approximate the area of the region P circled above. And the case where we have n equals 12 rectangles is the one that does it the best. Now we use rectangles because rectangles are easy for us to do. So we are going to demonstrate how to approximate this area using problem number 1. The area of a rectangle, as you will see up above, is given by the base times the height. So what we need to figure out is what is the base and the height of the rectangles that we are working with. That's going to depend on the number of rectangles that we are going to build. According to problem number 1, it states that we are going to be using 4 different rectangles. So now what we do is we're going to start defining some terms. The base of the rectangle is given by delta x, which is equal to b minus a, right, divided by n, and it's getting pointed to with the blue arrow. In our case, in problem number 1, we have that a is equal to 1 and b is equal to 3 and n is equal to 4. Therefore, delta x is going to be equal to 3 minus 1 divided by 4, which simplifies to 2/4, and using a calculator, we get that this is equal to 0.5. So we have that our interval is from 1 to 3. So now what I'm going to do is, since I've already identified delta x as being equal to 0.5, I'm going to write down the endpoints of this interval, which were from 1 to 3. And then I also know that the midpoint in there is 2. But the distance between each of these points, since I'm going to have 4 intervals, subintervals, it is going to be delta x or 0.5, meaning that these points that you see listed here are the partition points, since the distance between each one of them, let me put that below, is 0.5, as you can see from just subtracting those 2 consecutive points that you see there. So next, what we want to find is the height of these rectangles, because the delta x, as we saw from the definition, that's equal to the base of the rectangle. Now, how do we determine the height? Well, the instructions tell us what we use to determine the height. So according to the instructions, we are being asked to use the left endpoints of our interval. So let me single out these left endpoints. That's going to be, if I look at each of the bases, that's going to be those points that are being highlighted right there. the 1, the 1.5, and the 3. So to obtain the height, we use the function f of x. So to find height for each rectangle, we use the function f of x. So let's write down the function. We use f of x is equal to 1 over x plus 3. So then we're going to have 4 different rectangles. Let me just draw 4 generic rectangles. And what I'm going to also do is I'm going to label them so we have a good sense for what rectangles I am referring to. Since I'm using the left endpoint, I'm going to call this rectangle L1, the next one L2, L3, and L4. All of these rectangles are right next to each other. They share that edge that has gotten bolded right next to each other. So then I'm using the left endpoints, and I will do the following to determine the height. So then for the rectangle L1, we have that its height is equal to the function f evaluated at 1, and this yields the value 1 over 1 plus 3, which is 1/4, and that's going to give us 0.25. For the L2 rectangle, its height is going to be the function f evaluated at 1.5. This will yield 1 over 1.5 plus 3, which is 1 over 4.5. And entering this into our calculators, we will have 0.2222. For L3, we have that its height is equal to f of 2, and following the same process as before, and of course using our calculators, we get that this is equal to 0.2. And finally, for the last one, its height will be f of 2.5, and once again, using our calculators, we get 0.181818. And let me fix this over here. This value here, I accidentally wrote as 1.5. It should be 2.5. Okay. So next, I'm going to compute the areas. So the area of L1 is going to be f of 1 times delta x. So that is 0.25, that's the height, times 0.5. And using our calculators, we will get the product for that. Area of L2 is going to be f evaluated at 1.5 times delta x. Similarly for L3, its area would be f at 2 times delta x. We have all of these values, and then lastly, the area of L4 will be f of 2.5 times delta x. So we have, for each each of these areas and the numerical values, we get 0.125 for the first rectangle. For the second rectangle, we get 0.1111. For the third rectangle, 0.1. And for the last rectangle, we get 0.09090991. So all of these values that you see here that are getting highlighted in green are going to be added up together. And when we add them up, we're going to take the sum of all of these values. Let me actually use a different color here. Let's use yellow. So the sum of all of these that are getting highlighted right there, and we're going to get that they all add up to 0.42702, and this is an approximation to area of P1.